Hello, everyone. I'm Dimitra Chasanidou. I'm a postdoc researcher at the Norwegian University of Science and Technology, together with John Krogstie, a professor in the NTNU, and we collaborate with Sintef and Costas Boletsis, who is a senior research scientist. We will talk about the user experience in sustainable tourism. And before that, I would like to lay the ground and to introduce you the background of this work. As the Center for Sustainable ICT, we work a lot to develop and evolve the sustainable ICT solutions. We work in different projects together with academics and industrial partners. And we have several projects, some well-known, like the Go for IT, which is an arena for twin transition in Norway. And this is a collaboration between private business, academia, and the public sector, where the focus is mostly on sustainability and developing a toolkit to improve the sustainable solutions in several areas. Another case which we have worked in the past is the Gaia Vesterålen project, which aims to promote environmental awareness and sustainable development in the area of Vesterålen, which is in Norway. And another example, we worked a lot with sustainability of AI tools in the University of Oslo, is together with the library. So the first screenshot is from the Gaia Vesterålen, which is also a VR application. And the second one is actually the motivation for this work, a previous example of an app, sustainability design project, the Audioneer. Also, I would like to mention our definition on sustainability. We view sustainability as a multidimensional concept. Sometimes in the literature, they introduce three concepts. Environmental, technical, and economic are central aspects of sustainability. However, we view sustainability as a fifth dimensional concept, including also the social and the individual aspects. And therefore, this visualization illustrates the complexity, but also the three layers of sustainability with immediate, enabling, and structural effects. Our topic is on sustainable tourism, and we would like to minimize the negative impacts of tourism, for instance, over-tourism, and the effect of environmental degradation and economic disparities for a particular area. On the other hand, decision makers sometimes have multiple conflicting criteria, and therefore we should balance this to ensure sustainable outcomes in the short and long-term effects. MCDM, as we call it, multi-criteria decision-making frameworks, have been applied in the past, and they allow all the stakeholders to evaluate alternatives according to rates of environmental, social, and economic criteria. However, these approaches often lack transparency, meaning that the user cannot see the criteria and how the decisions are being made. AI and LLMs can effectively address this limitation, and we have a proof of concept for that, our preliminary work. Our goal is to explore the UI design to shape transparent AI-assisted decision support systems for the particular area of sustainable tourism. We have the case for the city of Oslo, and we developed a prototype for sustainable tourism recommender system that integrates both MCDM framework and LLM-based natural language explanation, which will prove that enhances transparency, usability, and user trust.
So to do that, we developed a prototype in the form of a web-based tour guide application. It was applied in the city of Oslo, and we had 13 places of interest, meaning tourist sites. It was developed as a proof of concept, so it's at a feasibility stage. And as you can see on the screenshot on the right, at first the travelers had to express their personal priorities through a lightweight kind of vanilla interface. And we had selected 4 criteria for the users to apply their own weights. It was real-time crowd capacity at the location, the weather conditions, the distance between the traveler and the place of interest, and the local air quality. Then we applied the MCDM formula that consists of the weights from the users as collected previously, and then data from for the other 4 criteria. For crowd capacity, we used simulated data since we didn't have access to any real kind of data. For the weather, we used the Meteorological Institute of Norway and their API. For distance, we used Euclidean distance, meaning the shortest path between 2 points. And for the air quality, again, data from the Meteorological Institute live data. Then we applied the board count ranking method, meaning that for each place of interest, there was a ranking when compared to other places of interest. And then we would apply the user weights and create a sum of all of those together, thus compiling the total score. All those recommendations, the rankings, were generated and displayed on an interactive map, as you can see on the screenshots, along with additional information for each place. And naturally, this MCDM formula was simplified since at this stage of at this research stage, the user interface was prioritized instead of content accuracy. Then we implemented a conversational assistant in the same user interface that was implemented with OpenAI's chat completion API. And it was integrated in the user interface as a button that would trigger a drop-down interactive box. And there we had like a minimal message sent to the API consisting of a static system prompt. It supported free text user queries, but only for the rankings, and included 3 predefined input options in order to assist, to help travelers that are on the go. The goal was to assess perceived usability, overall user experience, and also to gather qualitative insights into the transparency and interpretability of the recommendations. We had 13 users that was asked to role play a scenario where they were located at the Oslo Central Station, a quite central point in Oslo, and were intended to visit those 13 very popular places of interest. Then they could explore the application on their smartphones for 15 to 20 minutes. And then they were invited to complete a questionnaire consisting of demographics, system usability scale survey. I can see a question coming for that. but anyway, the SUS was only like a warm-up for the nice qualitative section that 6 open-ended questions on user satisfaction, usable features, the confusing or challenging aspects of the interface, how they interact with the LLM, suggestions for improvement, and how the application might influence their future travel planning decisions. What we found out is that it had nice usability. You can see the score up there. The integration of the real-time contextual data was highly valued, and the users felt that the rankings were nicely explained by the conversational assistant. At the same time, the weighting, the user-defined weighting lacked context. The free text queries were not related to the rankings. Actually, the free text queries that were not related to the rankings degraded the perceived performance of the assistant. And overall, we managed to identify some interaction gaps that we're going to address in future implementation, but definitely that was a constructive first step towards exploring the integration of MCDM with an LLM-based natural language explanation interface, always for sustainable tourism planning.
Actually, thank you for interesting. How just a clarification. So you had users actually role play in a lab environment, or were they actually located in the central
No,
station?
it was like an office environment.
Okay, and why didn't you do it in situ? Like
It mostly
practical
reasons, like the fact that it's still a feasibility study targeting to being integrated into another bigger project. So that was like a first step. Instead of doing like a workshop with pen and paper stuff and make a few sketches and say, would you like that in an application? We took it to a higher fidelity level.
Okay.
Because it was probably much easier to do that, to do like the technical implementation and the role play instead of going into a workshop kind of environment with pen and paper. So that's why it's a short paper. The contribution is, of course, is not huge, but at least it's practical in the sense that in future steps it's going to be integrated into another project that we have for visual impaired.
So are you planning to actually put it out for ecological validity purposes? Because obviously, being holding your device has an impact on the user experience for sure, and the usability perhaps.
So we studied that extensively in the past, so with regular users, and we also had a project with visually impaired users where the audio information in a tour guide context also important, so GPS based. And the idea here is to essentially how we integrate these MCDM algorithms in a way that is understandable by the users.
Congratulations, interesting. So it probably was my fault because I arrived a little bit late, so I missed the beginning. So just clarification question, like Maria. This is a recommendation provided, which is points of interest throughout the city of Oslo, which obviously would depend on the actual location of the user. So if I'm, I don't know, the northern end of the city, the recommendation perhaps because the distance from a point of interest will be different. So the ecological validity of doing this in a lab, it changes as discussed
definitely.
just previously. What I would like from this transparency to figure out is you have some terms in this formula which relate to the crowd, the weather, the distance, and the air. And try to figure out first how you define them, how to calculate them, and whether they're adapted and derived from the questionnaire at the beginning for each individual user. Just a clarification, because it's not clear for me how you do actually calculate this, which will impact the recommendation.
So those 4 criteria are empirical, so based on the previous projects that Dimitra presented, like here we had this one, and at the same time it was also practical, what kind of live data we can get. And I mean, we know in Norway weather and air quality is like number 1, even though air quality is never bad over there. So essentially we didn't focus on which criteria, because this is something that can change, but we focus on the user interface design. So the questions that were asked in the end was not like if, I don't know, air quality is meaningful for you, or if you would change your travel decision based on air quality, but if there was something that would give you suggestions based on what you would like weather or distance, would you take that approach? Would you take that recommendation? So that's why we're stating here that the formula is simplified. Naturally, it's way more complex to choose the criteria. It cannot just be 4 criteria in this stage. So at first we start with the user interface, and then at the end we're going to look at the backend which criteria we're going to choose. And this is something that can also be localized. Norway won't have the same criteria as Greece.
Maybe a quick follow-up on that.
Yep.
How would you consider to make this work applying other contexts? So as you said, Oslo or Norway in general might have different characteristics in other countries. If we were to apply that in Greece or Cyprus, how would we do it?
And I think my last sentence was like, first of all, change the criteria, localize the criteria. That would be first. Then also we have to see if it's an urban environment like city of Oslo, or if it's a rural outside the city. So yeah, but first of all, it's the criteria based on which the traveler should make their decision. And let's say Norway, it's weather or whatever. In Greece, maybe something else, but that should derive from literature.